Hello, in this video we are going to take a look at another problem. This is problem 9, and the name I've named this file kai1.c. I've created a file, I've named it kai1.c, and this particular problem is from this book, See How to Program by Deitel, 9th edition, exercise 5.49. Now the question says computer assisted instruction. The use of computers in education is referred to as computer assisted instruction, KAI. Write a program that will help an elementary school student learn multiplication. Use the run function to produce two positive one-digit integers. The program should then prompt the user with a question such as how much is 6 times 7? The student then input the answer. Next, the program checks the student answer. If it is correct, display the message very good, and ask another multiplication question. Now, if the answer is wrong, display the message and please try again. I'll let the student try the same question repeatedly until the student finally gets it right. A separate function should be used to generate each new question. This function should be called once the application begins execution and each time the user answers the question correctly. All right. So now let's see how we are going to achieve, how we are going to tackle this particular problem using our knowledge of C programming. All right. So as usual, we declare our header files that we are going to use in this particular program. So I know for sure we are going to make use of the standard input output header file. So I'll just write, let me jump 2 lines, and then after the comment, now I'm going to include hash include stdio.h. stdio.h, standard input output header file. So for now, let's maintain this one now, and then if we need more, we are going to come over and add them. All right, and then next I'm going to declare function main, int main void, and then transit, and then we have this. So let me comment here, and function main, and function main, and function main. All right, and function main. So as usual, I'll be going back to the question to see what we are asked exactly to do, and then we try to do it, accomplish that in our program. Do a best practice is for you to write an algorithm, and then you go over the algorithm and then try to translate that particular algorithm using the C programming language. But for now, we just let's do with the question. So this is not this is very much trivial stuff. We can be able to tackle this by going to the question. So it says we are going to write a program that will help an elementary school student learn multiplication. Use the run function. So you say you should use the run function. Now the run function is in a particular header file called the standard input output, standard library, not the standard input output, standard library. So let me come over and include it here, since we know that we are going to use function run, hash include stdlib.h. All right. Yes, and to use function run, to use function run. Right. Now to produce two positive one-digit integers, the program should prompt the user with a question such as how much is 6 times 7, and then the student okay. Now we should say a separate function should be used to generate each new question. Now this function should be called once the application begins execution and each time the user answers the question correctly. So that means we are going to make use of a function that will generate the multiplication question and print it out on the screen. So we know that we are going to make use of a function. Now I'm going to declare a function prototype. So I'm going to say we have a void multiplication and void. So void means that the return type is void for this particular function multiplication. For the function prototype, we have already covered this function, what a function prototype is. So this is a function prototype for a function called multiplication, and we declare that this particular function is not the return type is void, meaning that it's not going to return anything. Also the data type is void, meaning that it doesn't require the parameter has been declared as void, meaning that when we invoke this particular function, we are not going to pass anything to it as argument. So when we just call it like that, we start passing anything to it, and it is going to do its work as we program it. All right, so you are going to see how it is going to do its work exactly. So now we have int main void. So now let's go to the function main and then call this multiplication. So we say multiplication. Now as soon as we enter, so this means that as soon as the application begins executing, it's going to invoke function multiplication. All right, it's going to invoke function multiplication, and then multiplication will begin executing. So now we need to go and create this particular multiplication function and then code the necessary write the necessary code within the function multiplication so that it will generate multiplication question and print to the screen asking the user the question in particular. So now I'm going to go jump 2 lines here, and then I'm going to create I'm going to declare a header for my function. So I'm going to say void, and it must match what is on the function prototype. So I'll have void multiplication void. Then I will have the function body, and then I'm going to write my code within the function body. So this is invoking function multiplication. Let me make a comment here. Invoking function function multiplication. All right, so here we are. So here I can end function multiplication, end function multiplication. And function multiplication. Okay, so here we are. Now when you go back to the question, it says what does the question says? This program should prompt the user with a question such as how much is 6 times 7. The student input the answer. Next, the program check the student answer. If it is correct, display the message very good, and ask another multiplication question. If the answer is wrong, display the message no, please try again. So basically a program that will keep asking the user for a question, and if the user get the question right, it will continue until the user wishes to terminate the program. So that means what will come to our mind is looping iteration. So we should have a looping control structure with a means to exit out of the loop. We should place the means to exit out of the program in the user's hand, so that at any time he wishes to exit out of the program, he's going to enter a particular input, and then he's going to exit out of the program. That means he's going to terminate the application. If he doesn't answer correctly, the application will keep on asking him for the right response until he get the right response. And when he get the right response, the application will now ask a new question. All right. So now let's go and see how we can achieve this in particular. So what I'm going to do, let's give the user the means to exit out of the application at any stage. So I'm going to print this. I can say this is conversion specifier for a string. Okay, I can see enter -1 at any time to exit the application. Now the user can enter this -1 at any time to exit the application. So now we want to be printing a new question to the user, asking the user to answer the question, multiplication question. And as I've said earlier, what will come to our mind is looping control structure. So let's have it this way. Let me correct this. Let's have it this way. We have while. Now I can say while response. While the response is not equal to -1. Then I want you to continue performing these instructions. So while response is not equals to -1, it's not equivalent to -1, I want you to print continuously carry out this instruction. And the instruction that I want the program to do is to continuously ask the user for new multiplication questions. So but what is response? The program doesn't know any response. At line 40, it doesn't know anything like response. So we need to declare a variable response. So I'll just come up here, because the response can have I can take either answer to a multiplication question or -1 that the user will enter to exit the program. So that means definitely going to be an integer. So I'll have it as int response. So int response. So now I have in my while control structure, I'm now going to ask the user generate question and ask the user questions. So the question says generate single digit integers. The program should use the equation to produce two positive 1-digit integers. All right. So to do so, I have already imported standard library header file, and from it I will use function run to randomly generate equations. So I will say I'm going to declare integers, as I can say int number one is equivalent to rand, but it's a modulo 10. So basically what is going line 44 is going to do, it is going to generate for me a single digit integer that is between 0 from 0 to 9. From 0 to 9, because rand can generate any number, can generate 1 million number, a 1 million number, can generate 1000 as a number, it can generate any number. So but whatsoever the number is, we want to divide it by 10 and then take the remainder. Now this will ensure that the number 1 will only have the value from 0 to 9. Now that is the essence of using this modulo 10, for us to control the number, because rand because it is a random rand is a function that will randomly generate integers. So integers from positive integers. So positive integers, so to infinity. So from 0 to infinity, that is within the range of positive integers. So but we want to have the numbers, since the question says a single digit positive integer. So that is why we are dividing by 10 to make sure that whatsoever number we generate is between 0 to 9. And that is the modulo 10 will take care of that. And we have declared it as integer, and we have named that particular variable as number 1 as a variable to hold the number that we are going to get from this expression rand modulo 10. So now we go to the next number. We have int number 2. Number 2, we have rand modulo 10. Same thing, modulo 10. No, generate the first thing. Generate. Let me make a comment here. Generate the first single digit positive integer. Positive integer. All right, to generate for the first, and the other one generate the second single digit positive integer. So here we are again. Then let me comment this one also. So we have this, generate the second single digit positive integer. Generate the second single digit positive integer. So we have generated the numbers. Now the next thing is to add the multiplication question, so that we have okay, so we have so we've generated the numbers. Okay, now the next thing is to ask the user this particular question. Okay, let me go back to the question and see how we are going to. Okay, so we are going to how much is okay. So now we are going to ask the user the question. So I'm going to say print format single string conversion format control string conversion specifier conversion specifier for string. Okay, yes. Now we now ask the question how much. Okay, but I don't need that, because the number of arguments will be more than the what has been defined in this print format function. So I'm going to say how much is times. Okay, so now I'm going to replace this decimal integer format control string with the appropriate values. So so we have int how much is dash times that. So we have how much is in number one comma number two, right? So here we are. Now we have asked the question. Now we expect the response from the user. So now we make use of our scan format to get the response. So I'm going to say d comma and response at the store it in location of address of variable response. So now at this line number 48, we are expecting that the user is going to enter. Let me make a prompt here to signify it is a prompt, so that the user will know that it's going to enter something here. Now this particular line number 48 is going to get the response from the user and make it available to our program and store it in the address of variable response. So now next I'm going to check whether the response the user has entered. Remember, at line number 38 we have tell the user that he can enter -1 to exit out of the program completely. Now we need a way to check, has the user entered -1 to exit out of the application, or he has entered the right response to the question that we asked him. So to do so, I'm going to make use of another while control structure again, and this is called nesting, having one control structure within another. So here in this case we have nested two looping iteration control structures. So I'm going to have it as while I'm going to check, did the user entered -1 to exit out of the program? Now while the response is not equivalent to -1 and response now is not equivalent to number 1 multiplied by number 2. So do this following instructions. So here I'm checking to see, has the user, if the response is not equivalent to -1 and the response the user has entered is not the right response, then according to our program, remember the program asks us to keep asking the user to enter the right response. No, please try again. So no, please try again will continuously being printed until the user asks the response in a give the right response. So now until if any of these conditions is true, now and remember we are using AND, so both of these two conditions have to be true for the instructions that we are going to code within this while body to execute. So while our response, to make sure that the user has not entered -1 to exit out of the program, to make sure that it is not the right response that the user has entered, now before the instructions that we are going to code within this particular while body will execute. And what we want the instruction under this while body to execute is to simply print this particular statement. This particular string. We want it to print this particular string. We want it to print this particular string. Please try, and no, please try again. No, please try again. No, please, no, please try again. No, please try again. So let me copy it, and I'm going to paste it here. So no, please try again will keep on being printed, and no, please try again. No, please try again. All right, let me make a prompt here so that the user will know that it's going to enter something, and then I'm going to get the response within scanf function, and I'm going to store it in address of variable response. So and now the program will now check whether the response, if this condition still holds, the answer response is not -1, because if it is -1, then the program is supposed to exit, and if it is a response is not equivalent to number 1 times number 2, then this particular line number 53, line 54 will keep on executing. Now what if the user enter the right response? Then all right, let me end this. Let me make a comment here, and while also this, let me make a comment, and while. Now if the user enter the right response, then we need to check. Now if response is not equivalent to -1, why are we doing this? Why are we rechecking? Because line number 51, the response, these two conditions have to be true for the instruction within this while body to execute. Well, now what if the user did not enter, maybe the user have a correct response, that is enter the right response, that is the product of number 1 times number 2, he entered it correctly. Now this means definitely that with these conditions, line number 51 is going to fail, because response is not equivalent to -1, it is false, and the response is not equivalent to number 1 times number 2 also is false. False and false is false. So that means it is going to fail. That means line transfer of control of instruction, control of instructions will transfer to line number 59. But line P number 59 also, we need to check that the user has not entered -1, because now let's say now the user enter -1. Now if the user enter -1, we can see that response is not equivalent to -1 is false. A line number 51 is false, and response is not equivalent to number 1 times number 2. It's not equivalent, while the response is not equivalent to number 1 times number 2. Yes, response is not equivalent to number 1 times number 2, but it is one of the conditions is also is true, because -1 is not equivalent times to number 1 response, while response is not equivalent to number 1 times number 2. -1 is not equivalent to number 1 times number 2, and this is true, because if the user enter -1, then this is true. This is true. This is true, because -1 is not equivalent to number 1 times number 2. So where this is true and this is false, and true times false is false, response is not this is false. So that means that transfer of line instruction will not continue to line number 53. But since it is if it is -1, that means that the user has not entered the correct response. Then we need to jump to line number 63. All right. So now, but if the user enter the correct response, that means let's say the number 1 is 1 and number 2 is 2. 1 times 2 is 2. Now the user enter the correct number, the correct response 2. Now it will come to line number 51. Response 2 is not equivalent to -1 is true. 2 is not equivalent to -1 is true, and 2 is not equivalent to number 1 times number 2 is also true. All right, so I'm mixing things up. So response is not equivalent to okay, so I need to no, this is right. Response not equal. So 2, if the user enter number 1 times number 2 is 2. Now response 2 is not equivalent to minus 1. 2 is not equivalent to minus 1. Well, this is true. 2 is not equivalent to minus 1. This is true. And 2 is not equivalent to 2 is not equivalent to number 1 times number 2, which is false. So here in this case we have true and we have false. So true times false is false. So that means that the instruction in line number 53 and number 54 will not execute. So when it will transfer of control will jump to line number 59. Now response is not equivalent to -1. 2 is not equivalent to -1, which is true. That means now this particular loop will now execute because the user has entered the question correctly, has answered the question correctly. So now if the user answered the question correctly, what do we need to do? We need to print this particular string. Very good. So I'm just copy this here, and then I'll come inside this particular loop, this particular block, and then I'm going to print format. Then I'm going to have yes. Okay, sorry, please. I'm going to have this. Now I'm going to have what we have. Print this message. Very good. So it's going to print this message. Very good. All right, I have more than the required something. So let me delete this. Also let me delete this. So it's going to print this particular message. Very good. Now and then remember this is in the bigger while control structure. Then it will go back again and ask the next question. Now but okay, this is how is it. Yeah, this is how is it. Now what if the user enter -1? Now if response is not equivalent to -1, is it true? -1 is not equivalent to -1 is false. Then that means it is going to exit this particular while, and then let's print a message to show that the program is terminating. Control S. The program will not terminate. The program will now exit. So and then the program will exit. So this is how it is. But a little something addition that because we want to influence, as we have seen in a previous program, we need to make sure that we need to facilitate the generation of the random numbers. So we can seed the random number generation with the current time. So let me add another header file here. I'm going to call it it is called time.h, so that we can be able to use the current time. Time.h to use the current time, So also, and then in the bigger function main, I'm going to have I call another function to seed the random number generation of function rand. So now this will seed, what we call seed the random number generation feature of function rand. You can Google about this from the Google to see more about this particular srand and then the function rand and how we're using time and using time to seed the random number generation. So this is what we have. This program has answered this particular problem. Now let's go and compile this particular program and see if there's any error. Then we fix the error to make sure that the program is working correctly. So let me clear the terminal here, and then I'm going to see cd document where I have this particular file, and then cd programming. Okay, and then we have cd lectures. Okay, cdc, then cd, all right, lectures, ls. Okay, then we have all right, so gcc, my compiler, kai1.c, and then I want to output it as kai1. So I have an error. So here in function multiplication, while the response of each undeclared is reported for each function it appears in function multiplication, response undeclared appears used in this function. So we have a line number 53. Let's go back to line number 53 and see line number 53. Line number 53. Response. Okay, I misspelled it. Response. So response. Let me save it. Now let me go over again and try to recompile this particular program and see if the error has gone away. So luckily the error has gone away. Now let's run it and see how it's going to work. Alright, why is the directory? Sorry, Kai, and let's see. Enter -1 at any time to exit the program. Okay, so we're having an error. The two printouts are congested in one single line. So let me terminate the program. Let me go over and fix this issue. So we have how much is okay, at -1 to, so after printing it, let's move it to the next, to a new line using this escape sequence. So let's go back and recompile this program. Clear this terminal, and then we have this. So let's recompile it again, and then let's run it and see. Enter -1 at any time to exit the application. Still I'll need to make sure there's no modification to it. This is not the way I want it to appear. How much is all right? So let me, I want, as usual, let me just add those little formattings I used to do, just make it more nicer. So this, all right, so let me go back again. Let's compile it and then run it. Okay, how much is 0 times 0 is 0. Very good. How much is 0 times 4? 0. Very good. Still this is converted congested in one line. After printing out the something, let us print it on a new line. Let's have a new line character. How much is okay, the user will enter a response. Okay, all right, so let's have this, a new line character before this particular comment. Likewise here, a new line character for printing out this particular comment. So let's go back again to compile it. Let me clear the terminal to compile it, and then how much is 9 times 9? 81. Very good. How much is 9 times 8? Still I'm having this how much is, so the issue is, sorry, before asking the question, let's have it do something here. How much is, so let's have a new line character, and then we have this. Let's go back, gotta compile it again. So let's run it. How much is 3 times 3? 9. Very good. How much is 0 times 8? 0. Very good. How much is 9 times 0? Let's say 9. Incorrect response. No, please try again. 6. No, please try again. 7. No, please try again. 9 times 0 is 0. Very good. How much is 3 times 5 times 3? 15. How much is 4 times 4? 4. No, please try again. 16. Very good. -1 to exit the program. So program will now exit. So as we can see, this application is working perfectly, and this has answered the question in problem 9. So thank you for taking your time to watch this video, and please subscribe to my channel so that you'll be able to get a notification whenever I upload new C programming videos. Thank you.